This video is on the development of the periodic table. So what we need to understand is this always has not existed as this periodic table, this nice, neat arrangement of elements. It started that we just knew different elements. And in 1860, there were 60 known elements. And they were like the common ones that would be easier to find, like out in nature, for example. So chemists at the time were trying to determine properties, like how much they weighed, like per a gram. What did they react with? Were they solids at room temperature, liquids, melting points, boiling points? Those kind of properties. What was difficult is they were all using different atomic masses. So all over the world, they're all doing this. So when they're doing that, they're proposing just different possible compounds. So a group of chemists met and they came up with a convincing method for measuring their relative masses. So a mass compared to each other. They picked one element, carbon 12, and they compared everything to that. So this allowed chemists to agree on standard values for atomic mass. So then a scientist, around that time, 1860 to 1870, a scientist named Dmitri Mendeleev. Mendeleev was Russian, and he wanted to organize elements according to their properties. So he didn't just want this giant list or these groups of like, here's a group of 3 that are similar. He wanted more. And so what he did was he took the elements and he arranged them in order of increasing atomic mass. So he made this like a card for each element and he put them in order from smallest to biggest. And what he saw was every so often those chemical properties started to repeat themselves. Like for example, he might have had elements, like A, B, C, D, and then when he gets to E, he had similar properties to A. So it was almost like the row or almost like the properties like started over. And what he was able to do was create this repeating pattern. So he was able to take this giant list and make them into rows, where in the rows, the columns, so the up and down, were all similar to each other. And that repeating pattern is called a periodic. Like clocks are periodic. So like the second hand goes around and every 60 seconds it gets back to the top and starts over. So it's periodically going to do the same thing. It's going to repeating patterns. So he placed these elements by order of atomic mass, and what he found was that some of them didn't seem to fit in their group. So he actually put some of them out of order to put them with groups or columns that had similar properties. And so he left these empty spaces. And what he was doing was he was predicting that elements would be discovered later that had not been discovered yet. This is the super bold. This is the genius of Mendeleev's periodic table, that he was able to say, there's more we're going to learn. And I think it's going to go here. And he did way more than just saying, like, I think we're going to find another element. He was able to predict properties of those elements. And what's amazing is he was right. In 1871, they started to discover more elements, and some of these elements fit in these spots that he had predicted, and all of the properties were almost identical to what he had predicted. I mean, if that's not enough proof, I don't know what is. So other chemists then decided to accept his periodic table because at this time there were a bunch of different ideas, a bunch of different tables floating around. And when this happened, people are like, this guy's onto something. I think he's right. There was another guy who had a very similar table at the same time in Germany, but we don't talk about him much or his table because he didn't do this prediction piece. He didn't leave the gaps. So he didn't have the genius that Mendeleev had. All right, so 2 questions remained after he made his table. One was, why could most elements be organized by mass, but not all? Some of them seemed out of place when they were put in order by mass. And then why? What was the reason for this chemical periodicity? What was the reason for this repeating pattern? So before I go on to answer those questions, I want to show you a quick video of how, kind of the order of how the elements were discovered. So elements that were discovered first were these common metals that are easy to find, like in the earth or rocks or different substances. So like we're still in BCE. So this is a super long time ago when we're discovering all of these. And then we're going to jump to 80. So there was a while where there wasn't much at all. And now we're getting still more metals. All right. With hydrogen, oxygen was a huge discovery. Okay, so we're still getting, almost all of these are metals except for this carbon, nitrogen, oxygen, phosphorus, chlorine. And we're going to get up to Mendeleevs time. Okay, right here. So here's where his table came into play. So his table had these elements on it. They were in a different arrangement. It was more just like columns and rows, like a big old rectangle, but he left spaces. And the three that are usually pointed out are right here. So scandium right here. Below aluminum, they actually called it Eka aluminum because I thought it would be very similar to aluminum, and it was, which is gallium. And then germanium right here, which had properties similar to silicon, which they did know about. So then you can see as we go on, they found gallium and then scandium. And there it is, and germanium, proving him correct with his ideas. Now, what's a little different is his table was increasing in order of atomic mass. Now, if you look at your table, and I'll have it out, pull it out, look at it, they're not perfectly in order by atomic mass. They're in order by something else. And I'm going to come back to that. We'll let this finish out though. So you can see that very bottom row were the most recent to be discovered. These are all synthetic, made in a lab, not found in nature. They're all radioactive. They're all very short half-lives. You don't really want to be around them. Okay, so last one was 2010, but I believe these guys were just named more recently. So you may have heard about them being named recently. All right, so let me go back to this. So they're not perfect by mass, okay? And then what's the reason for this chemical periodicity? And it has to do with what a guy named Moseley figured out. So Moseley worked with, I forgot to fill this in, worked with a man named Ernest Rutherford. So Rutherford figured out that there was a nucleus in the atom, and that's where most of the mass was. And he determined that that mass had a positive charge to balance out with the electrons and the outer part of the atom. So working with Rutherford, he figured out that there was a nuclear charge, and that nuclear charge was due to protons. So if he realized if he arranged the periodic table in order of atomic number, that fixed some of the errors where some of the things were out of place. So if you look at your table, they are in order starting with hydrogen to helium to lithium, beryllium, etc. If you go row by atomic number, which is also why it's easy to find them by atomic number. And if you look at the mass, for the most part, they're in order by mass as well. There's a few that are flipped. For example, argon and potassium, 18 and 19. If you had those by atomic mass order, they would be in the switch spots. But potassium is a metal that's really soft that reacts with water, which if where it is right now, lithium, sodium, rubidium, those are all the same property. But if I put potassium over where argon is with these noble gases that don't react with anything, that are not metals, that wouldn't make any sense. So Moseley kind of just took Mendeleev's table and made it just a little bit better and helped us figure out why these trends are the way they are. So this leads us to what we call, what we call the periodic law. The periodic law states that when elements are arranged in order of increasing atomic number, elements with similar properties appear at regular intervals. So those are the periods. So that's why it's called a periodic table. There are repeating patterns when they are in order of atomic number. All right, so the periodic table then is an arrangement of elements in order of their atomic numbers so that elements with similar properties fall in the same column or group. So columns are vertical up and down. So the same groups, columns, they have very similar properties. And we're going to go through some of those, and I will show you some of those in class.